This is exercise 2.4.42 in your homework for chapter 2, where you're given a pie chart that displays some data, and the data displayed is here in this table. I've labeled each value of the data set X. So the first X value was 23.3. For those who were under 4 years, the next value of X was 43.3. For those who were 5 to 14 years, and so on. The first thing you're asked to calculate is the sample average. Well, the sample average is found by adding up all of the values of your variable, and the sum of these values is 327.3, and then dividing by the number of pieces of data that you have. And so if you divide that by 8, because there are 8 pieces of data, your sample average to 2 decimal places is 40.91. The symbol we typically use for sample average is X bar. The next thing you're asked to compute in this problem is the sample standard deviation. To compute sample standard deviation, we have to find the variance first. And I've put the variance formula up here in the upper right-hand corner of my screen. This symbol here is telling us to find the sum. And what we have to do is find the sum of all of the deviations from the mean squared. So these are the deviations from the mean. We're going to find that next, and then we'll have to square all those deviations. So I'm going to create another column here in my table, and I'm just going to call it deviations from the mean, X minus X bar. So I'm basically going to take each value of X and subtract that mean that I got of 40.91. So 23.3 minus 40.91 is negative 17.61. 43.3 minus 40.91 is positive 2.39. 17.4 minus 40.91 is negative 23.51. And so on for all remaining values of X. So I've displayed those deviations from the mean there in my table in red. Now what happens is if you add up all those deviations, except for a little bit of round off error, those will always add up to 0. And we shouldn't have a standard deviation of 0, because what standard deviation measures is the average spread away from the mean. Well, the only time the average spread away from the mean is 0 is when every value of your data set has the same value, the mean. And that's not what we have here. So to get a sum that's not equal to 0, we have to square all those deviations. So in this next column of my table, I'm going to take all of the numbers in red, the deviations from the mean, and I'm going to square them. Now remember, whenever you square a number, it turns out to be a positive answer, because squaring a number is just multiplying that number by itself. A negative times a negative is a positive, and a positive times a positive is a positive. So my first deviation from the mean was negative 17.61. When I square that, or multiply it by itself, I get 310.11. When I square the next deviation from the mean, 2.39, I get 5.71. And so on for all other deviations from the mean. I'm going to square each of them. So in the blue column here, I've recorded all of those squared deviations, but I've rounded them in my entry. I believe that MyLabs Plus is not going to want you to round until you get a final answer. So what I've done is I've added all those together, because that's what the numerator portion of my variance formula tells me to do. I need to add up all those squared deviations. And when I added them up without the rounding, I got 2,735.2288. That's the numerator portion of my variance formula. The only thing left to do then is to divide by n minus 1, one fewer than the number of pieces of data that we have. Well, we have 8 pieces of data, so one fewer than that is 7. So when I divide the sum of that blue list by 7, I get a variance of 390.7469,714. That's all that I can fit on my screen there. I'm interested in standard deviation. So the standard deviation is just the square root of that variance. So that number, 390.7-ish, I'm going to square root that, and then it asks me to round to 2 decimal places. So my average spread away from the mean in this case is 19.77. So when you look at your values of x here, which you know has a mean of 40.91, it seems reasonable that we would say that on the average, those values are about 20 away from the mean of about 41. So there's an example of a calculation of standard deviation. Any further questions? Just message me.